All right, welcome everyone. My name is Jeff Barr, and my session today is titled Cloud Computing, How We Got Here, Where We Are, and Where We're Heading. I'm the Senior Evangelist for Amazon Web Services, and wanted to start by giving you just a quick review of my background. I'm coming to you from my home in Sammamish, Washington, just outside of Redmond. I have a bachelor's degree in computer science from the American University, and I'm also a part-time graduate student in digital media at the University of Washington. I've spent some time at Microsoft working on the Visual Studio team. During the first .com boom, I was a consultant to startups and VCs, and I've been an Amazon employee since 2002. I published a book last year called Host Your Website in the Cloud, and you can see my picture and the book cover there, and if you'd like to get in touch with me afterward, my email address is there, as is my Twitter identity. So you probably noticed that the cloud is this kind of buzzword that seemingly emerged from nowhere and is suddenly everywhere. And my contention is that we've been building up to the cloud for about the last 50 or so years, and I did a little bit of research to kind of support that, and I'd like to share that with you today before we get into the details of my presentation. By the way, I should mention that if you do have questions relevant to the presentation, please feel free to drop those into the Q&A panel. I will be glancing at that as I speak, and I'll do my best to address questions as I go along. If there are things I don't get to, please feel free to email me afterward, and I'll be happy to follow up with you one-on-one. So here are some questions I thought about. What's the cloud all about? Where did it come from? Where are we right now? And where are we going with it? So what's the cloud all about? By analogy, I like to think of the cloud as very similar to your electrical services. You plug into your electrical grid in your home or your office. It's run by experts and designed to be as low cost and as reliable as possible, and available to you with more efficiency than if you could generate your power on your own. It's a utility service, and it's available to you on demand. The electrical utility measures how much power you use and bills you for your actual consumption at the end of each month. So the concept of the cloud is that it's also a utility service, designed and built by experts and giving you access to technology resources that are large-scale, available to you on demand, accessed over the internet with no upfront costs, and where you pay only for the amount of resources that you consume. So where did all this come from? I kind of picked an arbitrary date of 1960, which turned out to be a useful date because that's the year that I was born, and that's actually me right there on the slide. And it turned out that a lot of interesting things related to the cloud, I'll actually contend, happened in 1960. We had things like the invention of the RS-232 connection or standard. We had the modem, so we could start to communicate with each other. We had the IBM 1401 computer. Don't think flowchart templates were exactly invented in 1960, but I'll use that as a stand-in for the concept of systems design and systems architecture as something important. And then COBOL was invented around 1960, so that gave us the idea that high-level languages would become an important part of what we do. So communications, commodity computing, architecture, software, and business value all come together to really lay the foundations or the groundwork for the cloud. In communications, 1960s we saw the RS-232 and the modem. The 70s we saw Internet, TCP/IP, and ISDN. And in the 80s we saw things like DNS, DSL, and Ethernet. The 90s we had things like the Internet in a box to help people get connected and online. And then we saw commodity computing. The IBM 1401 was one of the first mass-produced computers. We saw in the late 70s, we saw the TRS-80 and the Apple II. In the 80s, we saw first the IBM PC, and then also the advent of the rack-mounted PC, so we could rack and stack vast quantities of these machines together in a very small amount of space. We also saw architecture begin to be increasingly important. So I think of architecture in a couple different ways, but I think of it as a separation of the design and implementation having something of a formal approach to what it is that you do. And also brings in elements of structure and modularity that become important as we think of the cloud as built from modular parts that we can connect and combine and recombine in many different ways. We've certainly seen a lot of advances in software, high-level languages, the idea of portable source code that we can compile in a number of different areas or machines, the easy ability to share that code, development of first a simple sharing of code via email and tapes, and then cooperative development and a more structured approach to that through various open source tools. Various concepts of early virtualization like IBM VM360, and after that, Zen. And then we saw the whole idea of the business focus. We saw organizations start to think about the value of IT. We saw them realize early on that IT was a crucial success factor, and we saw the position of the CIO become prominent and an essential part of an information-driven organization. So where are we right now? One can put any number of different ways to kind of check and say exactly where are we at on the innovation curve. I would say that we're probably at the early majority point. We've seen innovators and early adopters pick up on the cloud, and we're starting to see it accepted as a fairly mainstream aspect of putting a large-scale system together. So we could move that arrow to the left or the right a little bit, but I would say that as a rough guess, we're starting in at the early point of the early majority. So I think it's very important to realize that the cloud is not simply a technology model, and I think sometimes people miss the value of the cloud if they say, well, it's just a bunch of computers connected together. It's really important to realize that the cloud brings with it a new economic model. Very specifically, no capital expenditure, so you're not investing your funds in data centers and racks and servers and networks and switches. The idea of being able to pay as you go and to pay only for what you use. The ability to have this elastic capacity and to scale up and to scale down, which at first people would say, well, that's a technical issue, but I contend that that's really an economic issue, which says that you can more closely relate the cost of your IT to the actual amount of traffic and business that you're running through your systems. And then finally, improve time to market so that you don't have to put this investment ahead of time into actually scavenging and building infrastructure and finding real estate and so forth. You can more think in terms of architecting and allocating cloud resources. That picture there is simply a snapshot from my AWS account and showing you the actual pay-as-you-go model and the actual charges incurred for my account to date. So what are some of the common cloud use cases? These are some of the different things that we see at Amazon. We see a number of organizations going all with hosting, from various simple websites to complete applications to hosting of SaaS or software as a service applications. We see a number of organizations, including Amazon itself, hosting internal IT applications. We see content delivery and media distribution. This can be steady state, or this can be more event-based, where there might be a marketing promotion or a special event, webcasts, and short-term, kind of short-duration marketing activities that can take advantage of the scalable nature of the cloud. We see a lot of activity around the HPC, or high-performance computing space. We see a lot of folks doing batch data processing, map-reduce jobs, large-scale analytics, storage, backup, disaster recovery, very, very common cases. And then kind of the bread and butter that a lot of people look at as kind of a trial way to get started with the cloud is always the development and test environments. I really do think that the cloud is a great way to do any of these. Development test is a good way for people to get started, and especially when you start to think about ways to build things like reproducible environments, where you might have a large group of developers, and you want to make sure that each of them has a development stack that's configured the exact same way with the same security rules, the same software installations, the same moving parts, all put together in the same ways. So these are some of the more common use cases that we've been seeing for the last couple years at Amazon. So our offering in this space we call AWS, or the Amazon Web Services. Probably most of you are already familiar with this, but just for review, AWS is a cloud computing platform designed to be very flexible, very scalable, and very cost-effective, designed to fit and be a good value for businesses of all sizes located anywhere around the world. And one thing I like to point out when you are an AWS customer, you're using all the knowledge, expertise, and tools that have been accumulated as part of our repertoire of knowledge at Amazon since the company's founding in 1995. So why do people think this is a good idea? Let's take a look at a couple of sample applications. This is a graph we've been using for quite a while, and it still seems to really describe the situation quite well. So we've got time progressing to the right, and we've got the cost through our investment in infrastructure on the vertical axis. So we're putting something new online, a new business or a new website, and we do some homework up front, and we try to predict our demand, represented by the dotted line. In the traditional case, with traditional hardware, we'd need to invest up front, and we'd need to invest ahead of that predicted demand. So we would draw that line, we would do the math, and you can see that there's a stair-step model to that traditional investment, where we're making large investments. We're buying new servers at thousands or tens of thousands of dollars a piece each time we need to invest, and we need to always do that ahead of our demand to make sure that we always have ample hardware to meet our needs. So we put our system online, and what happens? So the red line now represents our actual demand, and at first the red line is safely below the blue line because our traffic has been in line with, or perhaps even a little bit below, our projections. But what happens if the red line is substantially below the level of hardware that we've acquired? We have this opportunity cost where we've effectively misallocated our resources. We've acquired hardware and other resources that we do not actually need to have in order to meet the needs of our customers. So that's not necessarily a fatal problem. We perhaps have a little bit too much in the way of resources, but we can probably survive that. On the other hand, perhaps things finally do take off, and they take off before we've been able to actually scale up to get sufficient hardware. In this case, the red line turns out to be ahead of our hardware purchases. So we have this red triangle representing the fact that people are going to come to our website, and we simply do not have the resources needed in order to serve them. That can be a fairly painful situation, which I sometimes call a success disaster. The idea that you kind of plan for and hope that you'll have this red line of growth, but then it happens, and you actually don't have enough resources around to deal with it. So the cloud model and this automated virtualization made possible because you can allocate new resources in a matter of minutes changes this. Instead of acquiring traditional hardware up front, you build a self-sensing, self-scaling system that can simply add and subtract resources on demand. And that's represented by that gold line. Here's a real-world example from one of our Amazon Web Services customers. This is a Wall Street application running for an unnamed hedge fund. And during their steady-state times, during their trading day, they run about 300 CPUs. And at the end of each day, they ramp up by a factor of 10, from 300 up to 3,000. They do their end-of-day processing and calculation for their risk management. And then at the end of that calculation process, they shut most of them down, and they go back down to their 300 steady state. They don't do any trading on the weekends, so they don't have any ramp-up necessary on the weekends, and they stay with their steady state level of processing. So this is essentially responding to a predictable or cyclic style of demand, where they probably have this on a scheduled system where they simply they launch new jobs, perhaps they launch new MapReduce jobs, and those just automatically allocate the CPUs needed to do the work. On the other hand, sometimes your demand is unplanned for or unpredictable. This is another now classic use case that we've been talking about for quite a while, but still it's a great example of the way that the cloud can help. This is one of our earlier customers called Animoto, and in the kind of the earlier days of Facebook, these guys put a Facebook application online, and it was a pretty cool application. The idea was it could take some of your pictures, you could hand it off some video, and it would then take the audio, take the pictures, and it would then compute based on doing a lot of image processing and some analysis of the audio and the patterns and so forth, would create a music video based on the pictures and the music that you gave it. So they put this out online on Facebook, and they did some adjusting to kind of how viral it would be, kind of decide how quickly it would spread from user to user. They were able to go from a steady state level on the 17th of 50 EC2 instances up to a peak of about 5,000 in just 3 days. So this is kind of one of the more extreme cases of what it means to scale and to have this just sudden, unanticipated level of success. Now when this happens to you, you always have to think that what were they doing during that steady state time? They were probably doing things like doing some testing and some modeling of their systems and their architecture. They were probably building in automatic scaling and load balancing, and they were thinking and planning ahead to say, okay, if we were to get this level of traffic, have we designed and architected the system such that we can actually sustain this level of growth? So not saying that this was without pain. This was certainly a very, very ambitious thing to be able to do for the cloud at that point in time, but they were able to handle that level of growth. Once they hit that peak, they realized that they could actually start using the cloud more efficiently. They realized they could do some tuning and some optimization. And even though their growth continued, they were able to actually scale off to different instance types in the cloud, make more efficient use of the hardware, and continue the growth while actually reducing the number of instances. So sometimes that's just what you need. Sometimes when you get this massive level of success, you need to be able to scale up quickly and say, I'm going to deal with it right now, with the systems that I have and the code that I have, but then once I get a better understanding of the bottlenecks that emerge at scale, I can over-invest in resources for a little bit while I actually address those bottlenecks one by one. So definitely something to think about. So this is a block diagram of our entire set of services. And let's just go through these from the bottom up to the top. At the bottom, we have a common layer that runs across all of our services that takes care of metering and billing. So this simply means that we're able to, as you consume these different services, we're able to track your usage. We can then identify your usage on a very, very fine-grained basis. So, for example, we can bill you for an hour worth of CPU time. We can bill you on a gigabyte month basis for storage, and so forth. At any point, you can always log into your AWS account, and you can see, as I showed you just a few minutes ago, you can actually see your actual consumption of your services. The next level up is called IAM, or Identity and Access Management. And this is a service that we've put into place because as our customers start to use AWS in more and more sophisticated ways, they're finding that they would like to have very fine-grained control of exactly which different services and resources each of the applications and each of the users is able to access. So when you put IAM into play, here's what happens. You start out, when you start to use AWS, you create an AWS account, and when you do that, you are given a pair of identifiers called the public key and the private key. You use those keys in the process of making requests to AWS and also to sign into the AWS account from your code. Those identifiers represent your AWS account, and as such, they have access to all the servers and to all the APIs and all the services and all the resources. When you can simply use those identifiers in your code and in your applications to access all of the resources in your AWS account. As you start to grow, you'll probably start to say, well, we have Department 1 here with some apps and Department 2 with some other apps, and we want to actually give more control. We want to make sure that Department 1 and Department 2 are not able to interfere accidentally with each other's resources. So what you do, you use Identity and Access Management to simply create a number of users, and each of those users then has its own public key and private key, giving you the ability to dole out those user accounts to the individual applications. So you would actually, in operation, you would create individual user accounts for each different application that you build, and then you have the ability to enable access to individual services, resources, and APIs using the Identity and Access Management. Now, unlike the AWS account that has full access to everything when first created, the individual IAM users have access to nothing. So they start out as identifiers without the ability to do anything, and it's then up to you to give them the access to those individual AWS services and resources as you see fit. So it gives you very, very detailed control of access as your AWS needs grow. Now let's go up to the next level of services, the compute, the storage, and the database. At the compute level, we have something called EC2, the Elastic Compute Cloud, which gives you access to servers on demand. These start out at 2 cents per hour, run a variety of different operating systems. We run multiple versions of Windows, Linux, OpenSolaris, and FreeBSD. We have a storage service called S3, the Simple Storage Service, which is very large-scale data storage and object-based data storage in the cloud. When you store your data in S3, it's automatically replicated to multiple locations, and the standard model of S3 storage gives you 11 nines of durability. So that means if you store 10,000 objects with us, we expect to lose an object about every 10 million years or so. S3 is a very, very big and very busy service. We currently store about 336 billion objects in S3, and we process about 200,000 requests per second for that information. S3 is made available to you on a gigabyte month basis, and what that means, that's a unit of both time and space. And the idea with S3 is if you store 1 gigabyte of data with us for exactly 1 month, we'll bill you 14 cents for that gigabyte month of storage. If you store data for a fraction of a month or a fraction of a gigabyte, we'll charge you that corresponding fraction of that 14 cents. The pricing is tiered, so as you go from storing gigabytes up to terabytes up to petabytes, your price per gigabyte becomes lower and lower. On the database, we have multiple offerings, and I'll talk to you in a bit about some of the details of some of these services, particularly the RDS, or Relational Database Service, gives you a hosted version of MySQL and Oracle, and the ability to make it very, very easy for you to launch database instances and to scale them, back them up, failover, and so forth. You can also install the third-party databases of your choice on Amazon EC2 instances. Moving up a level, the Amazon Elastic MapReduce lets you do Hadoop-style parallel processing. And like many of these services, what we're doing here is we're making it very, very straightforward for you to access these, to launch them through the console, to not have to deal with the low-level nitty-gritty details of the operation of these services. We have a global content delivery network called Amazon CloudFront, with nodes located in 18 different locations around the world. And we have multiple different messaging services, including the Simple Queue service for first-in, first-out style messaging, often used to build multi-stage pipelined applications. We have the Simple Notification service to let you do publish and subscribe style messaging. And we have the Amazon Simple Email service, or SES, which is designed for doing large volume email delivery, either on a bulk email basis, where you're sending the same email out to a large variety or large set of recipients, or transactional email, where you're sending individual emails out to individuals as site registration or purchase confirmation. Moving up one more level, up to the red level, we have Amazon Cloudwatch for monitoring. And the way Cloudwatch works is that a number of the different services actually publish metrics into Cloudwatch. Those metrics are stored for a 2-week period. We're talking about things like CPU load, disk read rate, disk write rate, and so forth. Those are stored in Cloudwatch. You can graph them in the management console, and you can also use those to derive scaling decisions. For example, I didn't talk about it in detail, but we have an auto-scale service that's part of Amazon EC2. You can create triggers or alarms that based on specific conditions, and those triggers can actually be used to drive scale up and scale down decisions. Moving to the right, the AWS Management Console is a visual tool to let you see and manage all the different resources I showed you on this page. AWS Elastic Beanstalk I will discuss in further detail later. It basically makes it very, very easy for you to build an application, upload to AWS, then we'll take care of creating the appropriate set of EC2 instances, setting up your block storage, setting up your auto-scaling, setting up your load balancing, managing log files, managing versions, and so forth. We have programming toolkits for a number of languages, including Java, PHP, Ruby, Python, and .NET. All these are available for free on our site. We have the virtual private cloud, or VPC, gives you a control of very, very advanced networking architectures in the cloud, and I'll discuss that in more detail later in my talk. And then Amazon Route 53 is a high-performance world-scale DNS service. So this is basically your repertoire of different services that you can choose from, and it's really important, I think, to point out that you can pick and choose between all these. When you start to build an application, you'll probably typically start with one or two of these. Maybe you'll start by simply launching some EC2 instances, maybe using a little bit of storage, expanding into database after that. But we do see our customers going step by step by step as they progress from simple to more complex use of the cloud. Now let's zoom into a little bit more detail on particular services, and let's start with EC2. The idea with EC2 is that you can launch servers on demand, so you get on-demand compute power. You can obtain and boot up these new server instances in a matter of minutes, and as a result, you can quickly scale your capacity up or down. The EC2 instances are available in 11 different instance types with a wide variety of CPU power, RAM, and local disk space, and they're billed on an hour-by-hour basis. And so we're billing by the actual number of hours that you have these instances running. So if you launch one at, let's say, 6 in the morning and you run it until slightly before noon, you will be charged for 6 hours of EC2 usage. Support for Windows, Linux, FreeBSD, and OpenSolaris, multiple versions of each of those. And then this is an infrastructure-level service, so you have the ability to launch an instance, log into it at root if you would like, and you can then install any tools, applications, middleware, and so forth that you would like on there. And you have the ability to deploy these instances across multiple availability zones inside of a particular EC2 region, so that any networking failure or physical security or things like that might affect any particular single AZ is generally not going to affect the other AZs in the same region. I didn't talk about regions yet, but we currently have 5 separate EC2 regions located in different parts of the world. We have 2 in the US, both East and West Coast. We have 2 in Asia, both in Singapore and in Tokyo. And our 5th one is in Europe. This is the full-scale architecture of all the different parts that you can choose to use in your EC2 systems as you put them together. So the first component in the top left is really important to know about, called the AMI, or Amazon Machine Image. And an AMI is effectively like a gold disk that your IT department might put together for you. And the AMI has your operating system, plus your applications, your tools, static reference data, and so forth installed in it. You build your AMIs once, and we give you a full set of tools to do that. Once you have done so, you're able to then launch multiple EC2 instances from that same AMI. When you launch your instances, you have the ability to launch them in any region of your choice. You can pick and choose regions. So when I talk about regions, I always like to emphasize the fact that you have the ability to address your storage and your processing at a particular region. So there's a kind of a common cloud misperception that you kind of pick up your data, you send it to the cloud, and you don't know where it is. The real fact with AWS is you know exactly where it is. We have 5 different regions, and you choose to direct your storage or your processing into one of those particular regions. The regions are then further subdivided into availability zones, and each of our regions has anywhere between 2 and 5 separate zones. The zones are connected with individual physical security, logical security, power, cooling, and so forth. And they're generally either separate buildings or independent rooms inside of a large data center facility, designed to give you additional fault tolerance in your system's architecture. When you launch these instances, you have 2 separate kinds of disk storage available to you. You have what's called ephemeral storage, which has a lifetime equal to the life of the instance. And you have something called EBS, or elastic block storage, where you can create block storage volumes anywhere from a size of 1 gigabyte up to 1 terabyte. You create these EBS volumes. You can attach them to any instance in the same availability zone, and you treat them as if they were a local file system. Create a file system on there, store files, retrieve files, and so forth. You can also do what are called snapshot backups from an EBS volume into Amazon S3. So that's your backup strategy. You can then use those snapshots to create new volumes in the same zone or in other zones in the same region. You can protect your instances by what's called security groups. And the security groups are what regulates any inbound network traffic to the instance. By default, when you create new instances, you have a default security group that has a very, very limited set of ports and protocols open to it. You can further narrow that down if you don't even want SSH or web access, or for particular applications, you can create new security groups that have additional ports, protocols, IP addresses open. We also have, if you're running inside of a virtual private cloud, you can also use security groups to regulate outbound network access. You have the ability to use IP addresses that we call elastic IP addresses. You allocate an IP address within a particular region, and you can then map it to any of your EC2 instances in that region. So if scaling up or scaling down instances, you can map that single IP address to any number of different instances over time. And then we also have a load balancing service that can spread an incoming web traffic load across any number of EC2 instances. And the load balancing works actually in conjunction with the auto scaling that you also see there. So you see auto scaling here and load balancing. These two work together. In fact, this works together very nicely with Cloudwatch. So Cloudwatch collects your metrics. You can then set some alarms inside of your auto scaling. And you can then set up alarms such that say when the average CPU load across my collection of EC2 instances gets higher than a certain level, I would like to add additional instances to the group. And when that happens, you can also arrange to add that IP address of the instance into your load balancer. And then you would make another alarm that says if my CPU load goes too low for a period of time, I would like to actually remove that instance from the group and from the load balancer and terminate the instance. So you can do these both. All this you can set up automatically, and you have also full programmatic API control over this setup. I see a number of good questions coming in, and I'm going to do my best to have some time to address all these good questions toward the end. There's one I should get to right now. Says EU law dictates that data may not be stored outside the EU. However, do your global sites have access to each other? So the idea with our data storage is that the data remains in the location where you store it, and the sites are not going to do any background copying of data from region to region without your explicit command. So if you choose to store data in the EU, it's going to remain in the EU unless you or one of your customers accesses it because you gave them access to it. We do actually have a security white paper that has a lot of details about the different ways that the different regions work together and how information is protected in those kinds of situations. Okay, so let's talk a little bit about pricing options. And again, when we talk about clouds and the fact that we have to look at the cloud as a business rather than just a technology, I think looking at different pricing options should help to make that clear. So there's three different ways that you can pay for your EC2 instances. The first one is the most obvious, called on-demand instances. And here you simply pay the list price as you consume your compute power. There's no upfront commitment. There's no long-term contract that you need to consume any minimum amount. And your cost for these starts at 2 cents per hour in the US East region. So that's kind of the most straightforward. Simply walk up, launch some instances, pay the list price. If you find that you have a continued need for CPU power and you can forecast your needs for a 1 or a 3-year term, we have something that's called a reserved instance, or an RI. The idea here with the RI is you can pay an upfront fee, and then once you've done that, you get a significant discount on the hourly pricing for the instance. This also gives you an assurance that the compute capacity is available when you need it. And what our customers will do is they'll typically run their systems for a couple months. They'll look at their average steady-state usage, they'll look at their growth, and then they'll start to do some math, which we're happy to help you with, to kind of help you figure out what is a reasonable number of RIs to purchase in order to reduce your overall costs. All of the billing is taken care of automatically for you for on-demand versus RIs. So you simply launch instances, and then we will take care to bill against your RIs first, and then only on-demand after you consume all of your RIs. Now, the third model is the most unique, and that's called spot instances. The model with spot instances is you actually bid for unused EC2 capacity. You create a machine image, you decide on a price that you would like to bid, and you then submit your bid either through our API or the command line tools or through the console, and you say, I would like to run this machine image, this many copies of it. I'm willing to pay up to a certain amount to launch those. And then we determine, based on supply and demand, we determine the spot price for each instance type in each region. And then if the spot price is below your bid, then your instances will start, and you'll actually pay the spot price. You don't always pay the bid. You might actually get cycles at a price below your bid. And then this is great for any kind of batch or background processing, where you have the ability to actually have computation that will run for a while, checkpoint itself, and have the intelligence to be able to pick up from where it left off should it be interrupted. So if the spot price rises above your bid, we will shut down your instances, and then if you've made a repeating bid, then we will reconsider your bid as conditions change in the marketplace. So this chart here gives you an idea of the different instance types and sizes that we make available to you. And so they're grouped into 4 families: the standard, the high CPU, the high memory, and the cluster. You can see here that there are both 32 and 64-bit instance types, a variety of amounts of memory from 613 megs all the way up to 68.4 gigabytes, and then varied amounts of local disk. On the micro, you have no local disk, all the way up to almost 2 terabytes of local disk on the high-end, high memory and cluster instances. The amount of CPU power varies between these, ranging from a very modest amount in the micros. In fact, the micros burst up to 2 what we call compute units, or ECUs. So the ECU is basically a 2007-era Xeon processor, and we basically have tried to benchmark and set a standard across all the different instance types in terms of that base benchmark processor. You can see that all the instance types, with the exception of the micro, have essentially a fixed amount of compute power or compute units. The micro is a little bit special in that it's designed for bursty processing, typically what you might see in handling web requests of some sort. So you get a very modest amount of processing, less than 1 ECU, for steady state usage, but then every so often when you get that web request and you need to do higher levels of processing, the micro will then burst up to a higher speed momentarily. Anywhere from 1 up to 8 virtual cores. And at the very, very high end, we have something called a cluster compute instance that, in addition to having dual Intel Nehalem processors, has a pair of NVIDIA Tesla Fermi GPU cards, which are suitable for very, very high-end graphical and mathematical processing with a high degree of parallelism. All these instance types have full access to the security groups that I mentioned, and you can see the prices listed there per hour for the Linux and for the Windows instances. So basically anywhere from 2 cents per hour up to $2.40 per hour for the Linux instances. These are all priced in the US East region, and the prices do actually vary slightly, about 10 to 20% different from region to region based on our own operating costs. We have a visual tool called the Aws Management Console that lets you log in. You log in with your AWS credentials, or you can log in as a particular IAM user. Once you've done so, you have access to all of your AWS resources through the tabs at the top here. So we have the set of tabs. As you can see, there are tabs for all the different AWS services. And for example, I have the EC2 tab selected here. I can see my instances. I can make spot requests. I can manage my reserved instances. I can create machine images, deal with block storage volumes, create snapshots, security groups, IP addresses, placement groups, which we haven't talked about, which are part of the cluster instances, load balancers, and key pairs. So all the different things you might need to do to operate on your instances and your AWS resources are available to you through the Management Console. I do actually have one of my EC2 instances selected here, and because I have it selected, the tab at the bottom actually shows me my Cloudwatch monitoring. So you can see it's not a very instance as I selected it. The CPU utilization was low. Not a whole lot happening on the disk or the disk writes, but it was actually processing some network traffic. So all these metrics are automatically collected up through Amazon Cloudwatch and stored and made available to you through the console. You also have a tab here called Tags, And the idea with tags is you can actually put name value pairs on each of your instances. So as our customers get to dozens or hundreds of instances, they actually want to be able to put some labels on them. So our tagging facility allows them to do so they can easily distinguish the different instances that they have. Okay. All right, so let's kind of take a look at where we're going. Let's take a look at some of the newest of the services. So I'm going to talk briefly about 4 of our different services: the Relational Database Service, the Virtual Private Cloud, the Elastic Beanstalk, and Cloudformation. So the Relational Database Service, or RDS for short, the whole idea here is you can provision a new relational database in a matter of seconds. We currently support both MySQL 5.1 and 5.5. And we have announced and will soon support Oracle Database 11G as well. Our RDS is designed to take away all the common administrative tasks from you and make it really, really easy for you to simply stand up and use a relational database without all the messy systems work behind the scenes. So you don't have to worry about hardware, operating system upgrades, database upgrades, database patches, scaling CPU, scaling storage, making backups, doing data restores. All those administrative tasks that are fairly messy and fairly complicated if you're running the raw database are all automated and made available to you through the Management Console. We are running the genuine database within RDS, so your existing MySQL or Oracle client code and tools and other administrative processes are still going to work against the RDS database. And you do actually get access to these databases on a pay-for-what-you-use basis with no upfront commitment. So you literally can get database by the hour with RDS. So here are a couple screenshots I took from the Management Console to give you a better idea of what RDS looks like in action. When you launch a new RDS instance, you simply pop open a wizard, and the wizard prompts you for some information. The first thing you need to fill out, I have here in the top right, is called the DB instance class. So here what you're doing is you're selecting from among 6 different sizes of hardware, from small up to quadruple extra large. So these are basically fairly close analogs to all of our 64-bit instance types. You can match the specs up to that pretty closely. So you select the kind of hardware you'd like to run. And we've already selected here that we're going to be launching MySQL. So you then get to choose your database engine version. So you can see that from this menu, you can actually launch any one of 4 different versions of MySQL. And we've got 3 separate versions of 5.1 and a version of 5.5 as well. And then a really important choice you get to make when you launch your RDS instance is what's called multi-AZ deployment. If you set this to yes, then we will actually launch a primary and a secondary RDS, and we will make sure that we have synchronous data replication from the primary to the secondary, so that as you store data on the primary, it's automatically replicated to the secondary. And we will also arrange for automatic failover if the primary is to become unavailable or to fail in some way. We'll automatically fail over to the secondary, and we'll immediately make that old secondary into the primary, and we'll create a new secondary for you. All that's handled behind the scenes automatically for you with RDS. You also get to specify how much storage you would like for your database. You can go anywhere from 5 gigabytes all the way up to 1 terabyte. You need to give your database a name, and you then have to also identify the database master user and database master user password in here. So we simply fill in a couple of pages of the wizard, and we're able to launch our database in a matter of seconds. It generally takes between about 2 and 5 minutes to get our actual MySQL database up and running. Once you've done that, you also have control of some other important things. For example, you can control your backup retention period. RDS will make automatic backups, snapshot backups once per day. By default, it'll do it in a predetermined time window, or if that's not convenient for your application, you can set a different time window. You also get to set what's called the maintenance window, and during that maintenance window time, if necessary, we can take your instance offline to install any patches that have become available for that database. As your needs grow, you might find that you need additional bandwidth to deal with the number of reads to your database. So you can simply right-click on any of your database instances and choose to create a read replica for that database. You identify an existing RDS instance. You pick a new identifier for your read replica, which type of machine you'd like to run it on. And again, in just a matter of minutes, you hit that create button and you can create a read replica for your database instance. You can even create multiple read replicas for each database instance to increase your read bandwidth as you add the replicas. Okay, so I talked a little bit up here about the backups. So each time that we do a backup for you, we create what's called a DB snapshot. The list of snapshots is available to you in the console. And if you want to create a new database from a snapshot, you simply go to the snapshot tab, and you click on the menu, and you choose Restore from DB Snapshot. So this will actually create a fresh MySQL database from that snapshot that was made of the database at that given time. So maybe you have a production database, you start to see some issues with your application. You can't seem to replicate it in testing because it's data dependent. So you simply make a snapshot of your production database, then you take that snapshot and create a test database from that snapshot, so you can actually move data from production to test very, very easily. And if you need to do some debugging or analysis against production data, you can do that without messing up your production database. Okay? So the next service we'll talk about is called AWS Cloudformation. And the idea here is that as people start to use AWS in more sophisticated ways, they start to go from having single instances to collections of instances and machine images and IP addresses and databases and S3 storage buckets and so forth. And they start to think about what if I could actually work on those things as a unit? What if I could actually make a description of that entire stack and then launch one or more copies of that stack with a single operation rather than actually putting those pieces together individually? So Cloudformation is our vehicle to do this. It's very, very straightforward to use. You use the JSON language to just define a template that indicates different AWS resources that you'd like to use. When you define that template, you can also define some parameters, and we will actually prompt you to fill in values for those parameters at the point when you're ready to instantiate that template. Once you have the template, you can then instantiate copies of it using either the command line interface or the APIs or the management console. And so if you're using the management console, you'd simply pull up the Cloudformation tab in the console. You'd select your template. The console will load the template for you, prompt you for the parameters, and Cloudformation then goes through your template, identifies all the resources that are needed, and it then determines the optimal order to create all those resources based on any dependencies. So it's going to create the items with no dependencies first, and then the things that depend on that, and forth in dependency-based order. Cloudformation is going to create all these. It is going to keep track of the identity of all the things that it creates in your, so you can then later operate on that stack as a unit. So if you want to actually shut the stack, you can do so with a single command. So we define the template, we load up the template, we create all the resources, and that template can be fairly simple if you a single instance, or it can be your entire business. It could be encoded in the space of a single cloud template. Here's an example of part of a template. See, at the top, this is actually simply setting up a load-balanced web application that runs across 3 availability zones and it's running in a pair of zones. It starts out with a couple of parameters. So the parameters in the template instance to be launched, the amount of disk capacity, the set of availability zones to run in, the port password for the database, and then the key and secret access key for AWS. The template then goes to define a set of resources, and those are things that are actually going to be. So a very, very powerful way to specify AWS resources with a single operation. Oh, let's see. So there was about our security one. There was the URL posted in that question was actually a fairly old URL. Please feel free to drop me an email, and I'll happily reply to you with a more current link to the security white paper. Let's talk now about the VPC or virtual private cloud. The idea here is you can actually create an isolated set of EC2 instances in the cloud, and you have full control of the network architecture and the IP address range inside of this isolated set of resources. You can choose to break it down into multiple subnets, and those subnets can be public or private based on access control lists that you create on the subnets. You can create filters for both inbound and outbound traffic at the subnet level and at the individual EC2 level. And you can also bridge your existing network in your organization. You can bridge that over to AWS using an encrypted VPN connection. Let's take a look at a picture of how that works. Okay, so this is a diagram of a fairly sophisticated network architecture created with the VPC. So everything up here in this cloud here is inside AWS. And you can see that what's happened is that we've set up a private IP address range, a 10.0.0/16 address range. We have created both a public subnet and a private subnet on subsets of that IP range. And then we have routing tables on the subnets. Traffic is allowed into each of those subnets. We've then extended the VPC with a pair of gateways. The first gateway is called the VPN gateway, and that's a bridge from the virtual private cloud and the resources in there over to your existing network. So your applications and your systems on your customer network can transparently access any AWS resources running in the VPC and vice versa, as allowed by the rules on the route tables. The second kind of gateway here is called the Internet Gateway, and the Internet Gateway allows the instances in the virtual private cloud to actually make direct access to the Internet and to other AWS services. So you have, when you create these virtual private clouds, they're fully isolated and walled off, and only by the gateways and by the routing tables and the rules that you create will you actually be able to enable inbound and outbound access to them. So lots of control, lots of power to create different network architectures, network topologies, and so forth in the cloud. Okay, let's talk for a bit about the Elastic Beanstalk. So the Elastic Beanstalk was designed to be a very simple way to deploy and manage an application and to take care of fault tolerance, scale, and administration for you. It's built around the concept of a container type, and the first container that we support is the Java language and then the Tomcat 6 application server. We have plans to support other platforms and other languages in the future. You simply upload your application in the form for the first container type, you upload it in the form of a compiled WAR file to AWS, and then we'll take care of creating all the AWS resources for you. You get full control of your application. If you want to go in and you can modify configuration settings, you can even take full control of the application and the configuration. But the idea is that the default settings and the ability to control them as needed will give you a very, very large amount of control of the specifics of the Beanstalk application deployment. So this is the structure that gets set up when you run your Elastic Beanstalk applications. You build your application in Java. You might choose to be kind of an old school developer like me and just build your application at the command line, or you could build it from inside of a visual toolkit like Eclipse. Either way, you build and compile your application, and then the end result is a WAR file. Once you have that, you simply upload that to Elastic Beanstalk, and you can do this from the console, generally the most common way, but we also have command line tools, and Beanstalk itself is a programmable API-driven service, so if you have an existing application that you would want to simply wire the Beanstalk deployment into, you can do that through the command line tools or the APIs. So you upload that WAR file, and then Elastic Beanstalk will create a version and an environment for each of those applications as you upload it. You can individually instantiate those versions into environments as needed. So what's actually inside of each of these environments? Let's take a peek at that. This is the environment that Elastic Beanstalk will launch for you each time you launch. We launch for you, automatically create your Elastic Load Balancer and your auto-scaling and a complete set of auto-scaling rules. We launch one or more EC2 instances for you depending on your configuration. And each of those EC2 instances has a complete stack inside. It runs the Amazon Linux AMI. We have the Apache web server installed. We have the Tomcat application server. And then finally, your application is in there. So we take care of all the details of getting this all configured, arranged, set up, and launched for you. Once you've done that, you're up and running. We automatically take care to forward your log files to Amazon S3 and make those available to you. As you upload new versions, you can easily create new environments. You can roll from version 1 to version 2, and so forth. Let's see. I see a question about, does Elastic Beanstalk support any other languages today? Currently, Java. We have plans, and nothing I can talk about, unfortunately, about where we're going next. But we certainly have had requests from our users to support a number of languages, and we're shaping our plans based on those requests. Okay, here's a couple of locations you can go for additional information. AWS website, the AWS blog, my email, my Twitter. Happy to hear from you and to answer additional questions. We have quite a few questions. I didn't quite get to them all. I see a few of you have asked me for slides. I'll happily share those with you. And let's see, what else can I discuss here? Okay, let's see, a question about, can you give us an update regarding the current AWS outage? Okay, so for that information, I would simply refer you to the Service Health Dashboard. Let me just paste the URL in for that, since that question does come up from time to time. So here's where we paste the latest, we store the latest information. I'm going to paste that in right here and send that to you. So there's a link that you can check on the latest status of AWS at any time. And there's a little more link over on the side. And if you click on there, you'll find extremely detailed status on AWS at any time. You can also scroll down to the bottom of that page, and you can get a backward operational history of AWS status over the last, I think, 35 days or so. Let's see. Someone asked, let's see, we talked about the EU already. Let's see, another question about, can Amazon EC2 automatically migrate my workload to another availability zone if something wrong happens to the current availability zone? So you would do this by way of auto-scaling and load balancing. And what you would do is you would simply create an auto-scale group, and you would use that auto-scale group to say that I want a certain number of instances to be up and running and healthy at any given time. So that's actually a pretty straightforward configuration to set up. And I think we've got time for one more question. Let's see. Oh, do you offer consulting or professional services? Yes, what we do is we have a set of solution architects, and the solution architects are happy to help you with design and architecture of your applications. We also work with a number of professional service organizations and partner organizations, and we have a directory on site that they're able to help you with design and implementation of AWS-powered systems. I'm getting the out-of-time signal, and it looks like we wrapped up just about on time. Again, my email is right there on the page. I would be very happy to answer follow-up questions for you. I see several of you have asked for materials and links, and I'll do my best to follow up on that this afternoon. I've really enjoyed speaking with you, and hope to see you running in the cloud sometime soon. Thank you so much.